Watch closely. A stationary wheel tumbles over. Yet when spinning, the same wheel stands upright and resists falling. This seems to contradict what we expect from gravity. Set two wheels side by side, one unmoving and one spinning. The stationary wheel quickly wobbles and collapses. The spinning wheel, however, remains balanced, upright, almost stubborn. What's happening here? This striking difference is our entry point into a fascinating realm of physics. The secret behind this stability is angular momentum. When an object spins, its mass moves around an axis, creating a force that wants to keep spinning in the same direction. This momentum is not easily changed. Imagine tiny arrows circling the wheel. These represent the direction and strength of its angular momentum. The heavier and faster the rotation, the larger these arrows become, locking the wheel's orientation in space. If you try to push it, the wheel resists, twisting in response. Angular momentum isn't just a scientific term, it's a force you can feel. Every time you turn a spinning bike wheel, you're experiencing this invisible order. Angular momentum shapes what we experience every day. If you've ever tried to balance on a stationary bicycle, you know how tricky it is. But once you pedal and the wheels spin, balancing becomes almost effortless. Similarly, a top remains upright as long as it spins rapidly. When it slows, it starts to wobble and eventually falls. Gyroscopes use this very effect to help airplanes, ships, and even spacecraft maintain their orientation. Engineers rely on spinning masses to stabilize everything from smartphones to satellites. Angular momentum is woven into the fabric of everyday technology and motion. One of the most captivating demonstrations involves a spinning wheel and a rope. Suspend the wheel from one end of its axle and let it hang motionless. It will drop straight down. But when you spin the wheel and then suspend it, something curious happens. Instead of simply falling, the wheel lifts slightly and begins to trace a circular path through the air. Gravity acts, but the angular momentum redirects the force, resulting in a motion called precession. It's a vivid, hands-on illustration of how spinning objects defy our everyday expectations. Motion does far more than move objects from one place to another. It provides stability, balance, and control, unveiling a hidden elegance in the laws of physics. The next time you watch a spinning top dance or ride a bike, remember the remarkable principle at work. Angular momentum is the reason spinning objects don't fall. They resist change, standing tall against gravity. In the world of physics, motion stabilizes as much as it propels. Tiny fact, Studiox.